Hello, cruel world. Today will be a day of demonstrating the strange but wonderful execution model in my CLI. In my previous episode, I previewed a prototype of a very mechanical stack-based model of execution that, through a few simple rules, much like a cellular automata or simple stack machine, or a protein complex, could provide rich behaviors to support the execution of structured command statements. A simple execution model that can be easily reasoned about. I should ultimately be able to pause, observe, trace, and when I combine it with the undo system I demonstrated in the previous video, I should be able to reverse execution itself. All in a model that has a minimum cognitive load with a state that can be compactly described. The reason for this will become apparent in future videos. Speaking of future videos, I've been informed that this is the best point in time to ask you, my various valuable viewers, to both like and subscribe to my future outputs, and on top of that, also follow me on the social medias. It seems a bit odd given that, for non-subscribers, this is most likely the very first time you've ever watched one of my videos, but studies show, apparently, that this is the moment to seize. So, on spec, having watched only this far and your first impression of me being mostly just me talking about subscribing, please go on and do just that. Seems entirely reasonable, apparently. Just giving you a moment. Okay, now that you've done that, let's start with some Q&A. What is this strange tool I use for diagramming? I use and endorse ASCIIflow.com. It's not an app, it's a website. You can only save diagrams in your local browser storage, but it's great, and I use it to design and document my code. I use an even stranger Japanese tool, but you've not seen that yet. That might appear in later videos when things get more complex. Now, a progress report. CLI undo. I have made a lot of progress with undo. A significant change has been to split the CLI up into separate actions and commands. Commands are, well, commands. These are the named things that do things. You type the name, hit enter, and it does the thing. But I've also added another layer, which is actions. This used to be a giant switch statement in my code that handled user input. Now, I have a pluggable system where I can inject and suppress actions as needed. Actions cover everything from typing and pressing enter to performing operations like undo and redo. Each action can have their own undo and redo operations, which means I can do this. But that might be a bit annoying if you just want to undo a command and not all the individual characters you typed. So my CLI has a 2-level undo, so I can undo individual edits or major changes. I have also exposed the undo history, mostly to help me debug. But in the future, this will expand into something that includes branching, so we will have something like multiple paths of reality and history that we can swap between. The reason for this will become apparent in future videos. Now, the prototype I demonstrated in my last video was for the shell execution model. My goal was to create an observable mechanistic execution model. I wanted something like a simple machine, almost like a cellular automata or protein complex. I know that a few of you out there are aware of my biologically inspired execution models that I use to evolve and render visuals for dance music.
Do you like to dance?
I like to construct systems out of the interaction of small, simple programs and use emergent behavior to perform useful computation. Everyone should have a hobby. This is mine. First, I want to introduce you to a concept I call a fold, which is code that can be executed in a logical container. Here, we can see that this is a fold and it contains a child fold that contains instructions. In the CLI, when we read an entry from the environment, we find the first topmost element of the deepest most fold, which in this case is the command true, which is a command that pushes true onto the status stack. Apart from reading, we can also add and remove elements that follow the environment mode rules, as outlined in the previous video. So, if I ask the environment for the command fold, it will return the container this command is in. If I ask to read a value from the environment, we will return the command itself. If we see no corresponding fold in the execution stack, but there is a command fold on the command stack, then this is the beginning of execution, a kind of point of ignition. There is a rule for this called initiate execution. The code is pretty simple. We look for a pending command. If there is one, we add it to the execution stack, but in its own fold. Once execution is underway, if we see the topmost execution fold is empty, then we need to dispatch the next instruction. There is a rule for that called continue execution. Its code is also very simple. We get the execution fold. If we have one and it's empty, and there's a command fold with at least one command, we transfer that command into the execution stack. Easy. Now, eventually we'll end up with an empty execution fold and an empty command fold. This signifies the end of execution of a statement. So we have a rule that looks for that condition called complete execution. When none of these rules can run, which means we have no commands to execute, we can stream the next statement from the statement queue onto the command queue. This rule is called schedule next statement. These rules, they're kind of like the rules of Conway's game of life. You keep running these in a particular order, and you get this complex execution behavior. I've added the ability to trace, pause, unpause, and step. As you can see, this is quite powerful. When I provide redo operations for trace, pause, play, and step, I should be able to step execution backwards as well as forwards. Also, when I start serializing the environment to storage between CLI sessions, I should be able to suspend and continue the execution of running commands. The reason for this will become apparent in future videos. What's next? Well, I have another prototype feature to show you. I touched on this in my first video, oh so long ago, when I mentioned repair theory and workflow discovery. If you look at how this CLI is structured, the encapsulated environment and type system knows ahead of time if a command argument is incorrect or missing, and should be able to provide some options to repair the command. It's a declarative system where information can be completed through evaluation of rules. Now, we learn through discovery and experiments. Undo will give us a level of safety and speed of experimentation, but we need some structure to pull everything together into a simple, compact conversation between mind and machine. There's been a lot of people playing about with autonomous AI agents that run in a loop of planning, action, and replanning with the goal of reaching an eventual goal. They are great at small things, but terrible at big things. They get confused easily on the big stuff and often disappear into strange but repeating pathological loops. Now, as an aside, my opinion is that a kind of multi-agent gestalt AI is likely where AGI or ASI will emerge from, and given some of the pathologies our own brains suffer from, we may be structured the same way. Levels and layers of holographic consciousness with a surface we perceive as our mind's eye. But I digress. Ah yes, the prototype. These strange planning and action loops, they should be a first-order thing in our software going forward. But maybe we need a system where the system itself is designed from the ground up to support what is coming. This prototype has a go at addressing the issue that very often a user knows their intent and maybe one or two words of power, but don't know how to get to the target of their intent or even what their intent really is. What if a system could guide the user? But what if that user was actually an AI agent? What I am saying here is that we need better tools, and we're focused on using AI to improve those tools. But we need to also be thinking about what kind of tools an AI will need, and what plays to their current strengths and minimizes their weaknesses. Okay, the prototype. I'll stop elking you now and just run the bloody thing.
Get on with it. Yes, get on with it!
I run a command. I want to create a session. It fails to validate because it knows it can't complete the request. What it can do is provide options on how to repair and remediate the problems. I want to create a session, but I'm missing a valid scope and a valid secret. Well, the scope knows where to get itself from. It can be done two ways. Also, secrets know where they can be obtained as well. And just in case I make a terrible mistake, I can back out completely. So I'm just going to Alt-1 to trigger the first option. It re-evaluates, and you can see I just have one option. Alt-1 again, and there we are. Now, What it managed to do was work out that it needed to obtain a secret and that it needed to be connected to a server. It guided us through that process. I can also resolve things like typos and formatting issues. Here, I want to save the secret, but as you can see, I've mistyped a critical option. I have again been given a number of repair options. Some of these are pretty automatic. Some allow manual intervention. You can see the prompt is yellow, which means I'm modifying the existing executing command. Starting the first example again, you can see that the prompt becomes red. This means I am in injection mode. I can intervene and have commands executed immediately to try and resolve what follows. Looking at the environment, you can see that these resolutions become stacked. If you remember my reference to recursive execution in the previous video, this is why. So, here I am solving the new problem I created. There. Now it jumps back to the original problem. Now, this is just the prototype. For the real version, I want the command to also have a crack at adding and ordering remediation options. And it goes without saying, its presentation should be easier on the eye, a lot less cognitive load. Now, you might ask, why am I doing this way? It's because I think the way we're approaching AI tools is very wrong. If you remember early handwriting recognition on the Apple Newton or Palm Pilot, it was impressive, but let's be frank, and we all knew it at the time, it was a bit awful. If you wanted to use the feature, you needed to modify your handwriting. Now, I'm not trying to retrofit AI onto our existing tools. I'm instead imagining what we will want and will need to be doing in 20 years, and what those enabling tools will be. And I want to build something that we can start to use now that also accommodates how AI can be used effectively, currently given its limitations, but with a view to progressing towards those ultimate tools instead of waiting 20 years. A big part of this project is exploring this domain. Also, I know it's strange that I'm talking about new future tools and starting with a CLI. And it's a good CLI, mind you, but maybe the reason is that this CLI is not just for you, it's also for them. I believe it would be best if we have a common set of tools for humans and AI for a common frame of reference. I also believe we need to start creating tools for them if we are to make the most of them as they are now. We need a kind of accessibility for AI. The reason for this will become apparent in future videos. Now, I've also been told that at the end of the video is also a good place to ask you to like and subscribe and follow me on Twitter and stuff. So, please do that. Goodbye, cruel world.